Z-Transform. So first, what is the meaning of transform? A transform is nothing but is an operation which converts a mathematical expression but in different format. Transforms. So transform is used for, suppose we consider a curve. That curve may be made simplified by transferring the origin of the coordinates to a new position. So transform is nothing but we can solve the problem is easily. We can use the transform techniques, I guess. So today we'll see the Z-Transform. Myself, I am R.Anbarasan. I am assistant professor in the Department of Mathematics, BSN College of Engineering and Technology, Tirunelveli. So yes, we'll see the Z-Transform. So the definition of Z-Transform. So Z of f of n is equal to sigma n equal to minus infinite to infinite f of n z power minus n. So that one is also called f of z, where f of n is a sequence defined for n equal to 0 plus or minus 1 plus or minus 2 is going on. So all the integer values. So this one is satisfied for all the integer values, and z is a complex number. So basic one is a transform. So z of f of n summation of n equal to minus infinite to infinite f of n z power minus n. So before that we know some formulas, some infinite series, some formulas, sin x and cos x, 1 minus x power minus 1, 1 plus x power minus 1, like this. So sin x, if you are familiar about that formula, x minus x cube by 3 factorial plus x power 5 by 5 factorial and minus and so on, minus 1 power n, x power 2n plus 1 by 2n plus 1 factorial. Then cos x formula 1 plus x square by 2 factorial plus x power 4 by 4 factorial is going on. Now 1 minus x power minus 1. So here this is a formula 1 plus x square x cube plus and so on. And another formula 1 plus x whole power minus 1, 1 minus x plus x square minus x cube plus and so on. If both the terms are minus means all the values are positive. If 1 plus 1 minus means this change plus minus is going on, right? E power x exponential function 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial is going on. Then another formula 1 minus x the whole power minus 2. Both the values are minus, so all the values are positive. This is a formula 1 plus 2x plus 3x square plus 4x cube is going on. Next, logarithmic function minus log of 1 minus x plus x square by 2 plus x cube by 3 plus and so on. So some basic formulas you want to solve some problems. Next, let's see down problem. Prove that z of n z by z minus 1 the whole square. You want to prove Z-Transform of n is z by z minus 1 the whole square. So first write the definition or Z-Transform. Z of f of n summation of, here we take only the positive values, n equal to 0 to infinite f of n z power minus n f of z. So z of n summation of n equal to 0 to infinite. What is our f of n? F of n is nothing but n. So n z power minus n. So summation of n equal to 0 to infinite. How to write z power minus n? 1 by z power n. So n by z power n. So this is infinite series. Now we apply n value 0 in here. So 0 by z power 0 is 0 by 0 is undetermined form. So we take the values from the positive values only. So we take n values 1, n equal to 1 we replace, but we get 1 by z power 1, so is 1 by z. Next, n value 2, so 2 by z square. N value 3, 3 by z cube is going on. So this is the formula is related to 1 plus 2x plus 3x square is going on. So here what is the x value? 1 by z, right? So 1 minus x whole power minus 2. we want to make that formula means we take that common value of 1 by z in here. So take common value 1 by z, what we get? 1 plus 2 by z plus 3 by z square is going on. So 1 by z. So this expansion is the formula of this one. 1 plus 2x plus 3x square is going on. So what is our x value? 1 by z. So here x value 1 by z. So 1 by z. Now consider this expansion. If any one form in this, the format means you write 1 minus x power minus 2. So 1 minus, here what is our x value? 1 by z, the whole power minus 2. After that we take the LCM z. So take the LCM z minus 1 by z, the power of minus 1, that means we take the reciprocal. Okay. So z minus 1 by z, take the reciprocal, what we get? Z by z minus 1 the whole square. Now square of this value, z square, numerator z square and denominator 1 z is cancelled. So what is the remaining? Z by the denominator the square, z minus 1 the whole square. So z of n, z by z minus 1 the whole square. Next one, find z of 1. You want to find z transform of 1. So z of f of n is a formula, summation of n equal to 0 to infinity f of n z power minus n. This is our f of z. So z of 1, that is our f of n is 1. So summation of n equal to 0 to infinity f of n is 1 z power minus n. So how does z power minus n? 1 by z power n, right? So now apply n value 0, 1 by z power 0 plus 1 by z power 1 plus then n value 2, 1 by z square is going on. So z power 0, anything power 0 is 1. So 1 by 1 1 plus 1 by z plus 1 by z square is going on. So this is the expansion of here 1 plus x square and so on, 1 minus x power minus 1. So here what is the x value? 1 by z. So 1 minus 1 by z the whole power minus 1. So take the LCM, multiply z in here, z minus 1 by z power minus 1. So take the reciprocal of this one, z by z minus 1. So what is z of 1? Z by z minus 1. Next, to find z of 1 by n, where modulus is greater than 1 and n is greater than 0. Write the formula z of f of n, summation of n equal to 0 to infinity f of n z power minus n, that is our f of z. Here what is our f of n? 1 by n. So 1 by n z power minus n, z power minus n go to the denominator. So 1 by n z power minus z power plus n. Now apply n value 1, what we get? 1 by n value 1 z power 1. So 1 by z plus n value 2, 1 by 2 z square. Next n value 3, 1 by 3 z cube is going on. Right. So now this is the expansion of x plus x square by 2 plus x cube by 3 plus and so on. There is a formula of minus log of 1 minus x. So here what is the x value? 1 by z. We apply x value 1 by z in here. So minus log of 1 minus 1 by z. So take the LCM z minus 1 by z. So that minus 1 is go to that power, that is m log n, log of n power m, log of z minus 1 by z, the whole power minus 1. So take the reciprocal of this one, what do we get answer? Log of z by z minus 1. Next one, find the z transform of 1 by n factorial. 1 by n factorial. So z of f of n, sigma of n equal to 0 to infinity f of n z power minus n, that is equal to f of z. So z of 1 by n factorial, summation of n equal to 0 to infinity 1 by n factorial z power minus n equal to summation of n equal to 0 to infinity 1 by n factorial z power minus n go to the denominator z power plus n. Now apply n value 0. So 1 by 0 factorial z power 0 plus, let's apply n equal to 1, 1 by 1 factorial and 1 by z power 1. Next n value 2, 1 by 2 factorial 1 by z square is going on. So 0 factorial value is 1, anything power 0 is 1. So 1 by 1 is 1 plus 1 by 1 factorial 1 by z plus 1 by 2 factorial 1 by z square is going on. So this is a formula of 1 plus x by 1 factorial plus x square by 2 factorial is going on. Okay, so here what is x? That is 1 by z, that is our x. So this is the expansion of, is the exponential function e power x. So e power, what is the x value here? 1 by z. So e power 1 by z. So z transform of 1 by n factorial e power 1 by z. Next, want to find z of a power n. So z of f of n, summation of n equal to 0 to infinity f of n z power minus n f of z. So what is our f of n here? A power n. So a power n dot z power minus n. So summation of n equal to 0 to infinity a power n z power minus n go to the denominator z power plus n. Then now apply n value 0. So anything power 0 is 1. Denominator is also anything power 0 is 1. So 1 plus, next n value 1. So a power 1 by z power 1. So a by z. Next n value 2. A square by z square. We write a by z the whole square is going on. So this is the expansion of 1 plus, we write that expansion of 1 plus x square plus and so on. This is a formula of 1 minus x power minus 1 is a binomial expansion of that. Okay, yes. So here what is the x value? A by z. So 1 minus, what is the x value? A by z power minus 1. So power of minus 1 means we will take the reciprocal of that. So 1 by 1 minus a by z. So take the LCM z. So multiply z here, z minus a by z. So 1 by z minus a by z. So take the reciprocal, we get the answer z by z minus e. So what is z of a power n? Z by z minus e. Next one, find z of minus 1 by 3 power n. Okay. So here what is the a value? Minus 1 by 3. Already we know that z power a, z of a power n is the formula. See the previous one, a power n is z by z minus e. Just we replace a by minus 1 by 3. So z of minus 1 by 3 power n, z by z minus of a value minus 1 by 3. So that minus z minus plus. So z plus 1 by 3. So take the LCM 3. So multiply 3 here. So 3z plus 1 by 3. So take the reciprocal. 3 is go to the numerator. So 3z by 3z plus 1. Next, find z of 1 by n plus 1. Already we know 1 by n. Here now 1 by n plus 1. So z of f of n, summation of n equal to 0 to infinity f of n z power minus n. That is our f of z. Right. Then z of 1 by n plus 1, summation of n equal to 0 to infinity 1 by n plus 1 z power minus n. Z power minus n go to the denominator, z power plus n. Okay. Now apply n value 0 here. N value 0 means 0 plus 1, 1. Anything power 0 is 1. So 1 by 1. Next n value 2. Sorry. N value 1. So 1 by 1 plus 1 z power 1. So 1 plus 1 is 2. 1 by 2 z. Next n value 2. 2 plus 1 is 3. 1 by 3. N value 2. 3 z square is going on. Next. So we have to use this formula in here. Which formula? X plus x square by 2 plus x cube by 3. So we want to use that formula means we want the z value in here. So multiply and divide by z. Okay, both and numerator and denominator. So z by z plus here z by already 2z in here. So multiply z 2z square, that plus z by 3z cube is going on. So take the common value of z. What is the remaining? 1 by z plus 1 by 2 1 by z square plus 1 by 3 1 by z cube is going on. So now this is the expansion of this one, x plus x square by 2 plus x cube by 3 and so on. So here what is the x value? 1 by z. So this is the expansion of logarithmic function. So minus log of 1 minus x. So is it in here? Minus log of 1 minus, what is the x value? 1 by z. So we apply 1 minus x value is 1 by z. So take the LCM z, what we get? Z minus 1 by z. Then this minus go to this power. So z log of z minus 1 by z power minus 1. So z log of, take the reciprocal of this one, z by z minus 1. Right. So z of 1 by n plus 1, z log of z by z minus 1. Next, this is a direct formula. instead of cos n theta and instead of sin n theta. Instead of cos n theta, z into z minus cos theta by z square minus 2z cos theta plus 1. And instead of sin n theta, z sin theta by z square minus 2z cos theta plus 1. Both of them have the same denominator. Numerator only the change, right? So this problem based on that. Next one here. So here we want to find cos n by 2 and sin n by 2, right? So how we can find this cos n by 2 and sin n by 2? So see the previous one, just we apply theta value by 2 in here. So z cos n by 2 here. So put theta is equal to n by 2. So z of cos n by 2, z minus z cos by 2 by z square minus 2 z cos by 2 plus 1. But you know cos 90 degree, cos by 2 is 90. So here cos 90 is 0. So z of z minus 0 by z square minus 2 z cos 90 is 0 plus 1. So z minus 0 is z, multiply z square by denominator z square, this term will be 0 plus 1. So z of cos n by 2, z square by z square plus 1. Yeah. Next, z of sin n by 2, so substitute n value by 2 in here, right? So in the previous one here, apply n value, theta value is n by 2. So z sin n by 2 by z square minus 2z sin by 2, no, the denominator is same, cos by 2 plus 1. So z sin n value is 1 by z square minus 2z cos 90 is 0 plus 1. So z into 1 is z by z square, this one is 0, so this is plus 1. Next one. Next, the differentiation in the z domain. Yeah. So in the Z-Transform we can apply both differentiation and the integration properties. So first, differentiation. If any one function multiply with the n, that is z of n into f of n, then is the direct formula minus z d by dz of f of z. So if any one function multiply with the n means first we find the Z-Transform of that function, after that we make the derivative of that function, right? So z of n into f of n equal to minus z d by dz of f of z. Now let's see the one problem based on these differentiation. So z of n square, we want to find z of n square. So how to write the z of n square n dot n? So function multiply with the n, right? So we apply the differentiation in the z domain. So here, so z of n square minus z d by dz of n. So z of n square minus z d by dz of, what is z of n? Let me know z of n, z by z minus 1 the whole square. Right. So that already we saw that z of n. Yes, z of n already we know, z by z minus 1 the whole square. So we apply in here. So z of n here, z by z minus 1 the whole square. Next, to take the differentiation of this one with respect to z, right? So we apply the formula d by dx of u by v. So u by v formula, u dash v minus v dash u by v square. So we choose that u value as a numerator is z and the v value is denominator z minus 1 the whole square. U dash differentiate with respect to z differentiate z is 1. Then differentiate of this one, consider this the whole value is z. So z square is a differentiation 2z, so 2 into z minus 1. Again differentiate this z with respect to z, we get 1. So this u dash and v dash u v value apply in that formula. So minus z u dash v, right? So u dash value 1. What is the v value? Z minus 1 the whole square. Then the formula minus v dash u. So u value is z and v dash value 2 into z minus 1 by b square. So 2 minus 1 the whole square, So power 4. So next, so to simplify this one, okay, consider these two terms, first and second term. Take the common value z minus 1. Okay, so already minus z, take the common value z minus 1. So what is the remaining? Z minus 1 minus 2z by z minus 1 power 4. Now, so this is z minus 1 and the power of 4, one time is cancelled. So remaining minus z and z minus 1 the whole cube. So numerator value is z minus 2z, z minus 2z is minus z and minus 1. Take the common value of minus, so that minus and minus plus, then multiply the z, so z square plus z by z minus 1 the whole cube is z of n square. Okay. Next, how to find z of n into n minus 1, n minus 2. So multiplication of three function. So after make the simplification, then we apply that the differentiation formula, right? So z of n into n minus 1, n minus 2. So multiply n in here, n into n square, n cube, n into minus 3n square, n into 2 is a 2n. So now take the Z-Transform of each function. So z of n cube minus 3 into z of n square plus 2 into z of n. Next we want to find z of n cube. Yeah, already we know how to find z of n square. So we take the definition, apply that, f of n is n cube. After simplification we get z of n cube is z cube plus 4z square plus z by z minus 1 power 4 minus 3. Already know the z of n square value, z square plus z by z minus 1 the whole cube plus 2 into z of n value, z by z minus 1 the whole square. Now simplification of this one. So take the LCM, the maximum value is z minus 1 power 4. So the same numerator here, z minus 1 the whole cube only. So multiply numerator by z minus 1. So minus of z minus 1, multiply 3z square plus 3z. Here denominator z minus 1 the whole square only, but we take the LCM of z minus 1 the whole cube. So multiply numerator by z minus 1 the whole square. Here 2 into z, 2z. Next. So the same first term z cube plus 4z square plus z. Next, the multiply 3z square in here. At the same time multiply the minus. So minus 3z cube. Then multiply this 3z square minus into minus plus 3z square. Then here 3z into z is a 3z square and minus and minus plus into 3z. And here this one expansion of the a minus b the whole square. So z square minus 2z plus 1. Multiply 2z, we get answer 2z cube plus 2z minus 4z square by z minus 1 the whole cube. We make the simplification. So plus z cube, here the 2z cube, 2 plus 1 is 3z cube, minus 3z cube is cancelled. Then z square, 4z square plus 4z square minus 4z square cancel, and plus 3z square minus 3z square is cancelled. Only have the z term. So plus z plus 3z plus 2z. So addition of these z terms, 1 plus 2, 1 plus 3 is 4, 4 plus 2 is 6. So answer 6z by z minus 1 power 4. So z of n into n minus 1, n minus 2, 6z by z minus 1 power 4. So these are the basic one for the differentiation. So again one time we recall that for the definition of Z-Transform, z of f of n, summation of n equal to minus infinite to infinite f of n z power minus n. So this is called the, we consider take as both minus infinite to infinite. If we take only positive value means we take up to 0 to infinite. Yeah. So that one is 0 to infinite f of n z power minus n f of z. So transforms already know, transform is nothing but if we can easily solve the differential equation, we making the after that some using the some few formulas. Right. Yes. Thank you.